So currently you can see I'm connected with the admin account. That's why you can see the status is the admin, and here I'm getting this two function deposit. So right now the total number of supply I have in this particular contract is 3010. I can easily deposit more and I can increase the supply. Current available token we have in the ICO contract is 2801, and this is the price of our token on which we are selling, and so far we have sold our 209 token. So if I want to deposit more token into the contract as an admin, I can do that, because you can see this is the remaining balance I have in my account. So if I want to deposit, let's say like 50 token more into the contract, I can click on this deposit token and it's going to do the initialization, and I have to simply confirm. And here you can see I'm transferring 15 token to my ICO contract. This is the fee. Let me simply confirm, and the transaction in the process, and finally we have transfer. Click on this OK, and here we have funded our ICO contract with more 50 tokens, so user can purchase. If I want to buy as an admin, I can do that. So I can simply withdraw the token which I have funded in my ICO contract. So if I want to withdraw like say 50, I can click on this buy token and I will buy, and this will be simply come here. You can see I'm buying 50 token, and you can see this time we are not charging the fund, because admin going to receive all the fund when the user will purchase. So that fund will straight away transfer to the admin address, not in the contract. So let's simply confirm, and here we have successfully bought the 50 token. If I click here, it's went down to 1. So this is how admin can control the contract after it's got initialized. So when you will deploy a contract for the very first time, you have to deposit your SPL token which you want to sell in the contract. Once you initialize that, then users are ready to purchase your token. Now what I will do, I'm going to simply switch my account. So I'll simply click here and I will go back to my account number 2, which is not the admin. So I have to simply redo the page. And right now you can see I'm connected with the different account, which is the user. If I want to purchase, right now I'm getting this only button, buy token. So I can simply give my quantity which I want to purchase. If I want to purchase 50 of the token, so if I want to buy, let's say 50 token, you can able to find the details like this much token I'm buying, this is the cost I have to pay, this is the network fee which is the estimated, this can go a little high, and here the total amount you have to pay. So I'll simply click on this buy token and it's going to make a call. Here we are making the call. You can see the network fee, and we are paying for buying the token, and this fund will transfer straight away to the admin address and we'll get 50 tokens. So simply click on this confirm, and the transaction is in the process, and here we have successfully bought the 50 token. I'll simply click on OK and it's done. So that's how we can buy the token, and you can see this went up to 504. This is how our Solana ICO PreSale DApp would work. Anybody can come and they can buy our token. I hope you have understood that how everything is going to work. Now we can start working on our project. So the very first thing we have to do, we have to create a folder, and let's call this Solana ICO DApp. You can call whatever you want, and this is the folder in which we're going to write the complete code for this particular project. So this is the folder you have to open in your VS Code. So let's click on this VS Code, go back to open, go back to desktop, and you have to drag and drop the folder in the project. Let's close this one, close all of this, open tab, and now let's make on the biggest screen. Right now you will find that I don't have anything in this particular directory. It's absolutely empty. If I open my terminal, you will find that I am using the latest node version in the project, so it's absolutely compatible with the latest node version. So now we have to get the starter file for this particular project so we can start working straight away. So what we have to do, we have to open our browser and we have to come back to the blockchain coder. There you will find all the project we have developed. So we have more than 95 plus project we have developed. So make sure to come back here, go back to the source code section, and there you will find all the project, whether you want to build for Ethereum, Binance or Solana. That's all the project which you will find. So we are building for Solana. So click here and type Solana, and you will find all the project we have developed for Solana blockchain. So you can see how you can create your ERC20 token with custom feature, and that's all the things which you will find. So we have the NFT marketplace, NFT creator, all of the project which you'll find related to Solana. So build at least 5 of them, then you can able to understand that how decentralized application work on the Solana blockchain. And this is the one which we are developing. So click here, you will come back here, and here you will have the complete resources. So you can take the final source code or you can get the starter file. So we are developing the project from scratch. So I'll click here and it will take me to GitHub, and here you can able to understand the complete folder and file structure we have developed for this particular project, including the technology we are utilizing. So the only thing we have to do is to simply clone this particular repository. So you can simply clone it and download it from here, but I already have the URL, so I can simply copy the URL. I'll come back to my code editor. Now I have to simply give the command. So I'll say git clone, and I have to paste the URL, and I have to give this dot. So it's going to clone the repository in this particular directory. So if you don't give this dot, it's going to create a new folder, and I don't want to create a new folder. So hit enter and you will find that we are cloning the repository. So we have cloned the repository successful. Now we have to simply click on this delete, and we have to delete this one. Now let me give you a complete walkthrough of the entire architecture, that how we have designed, then we can start working straight away on the contract. So the very first folder you will find in the project is the contract, in which you will have this particular folder called Solana ICO.rs. RS stands for Rust. So this is the extension which you have to keep in mind, in which we have to write the complete smart contract using the Anchor framework. So it has all the feature for allowing user to buy the token, and we can transfer. So tons of things we're going to add, and it's going to be a very huge contract. So this is the contract section we have. Now we have the library, in which you will find that here we have the idle.json file. So when we'll deploy the contract to the Solana blockchain, we'll get the API. You can call it API, you can call it idle file. So that's the idle file you have to provide here. Then you can able to communicate with the smart contract which already deploy on the chain, and that's what we're going to get it. I'll tell you how you can get it. So close this one. Now we have the pages. So it's going to be a single page application. We have this app.js. There you will find that here we have to do the setup for the context management and for our wallet. So that's what we're going to do, and we're going to also do the configuration for the network. So if you want to do the testing and deployment on the mainnet or a devnet, you can control it here. So all the testing, all the deployment of the contract, I'm going to do on the devnet. Got it? Now close this one, come back to the home page, and here we're going to write the complete code for our application interacting with the smart contract. Close this one, come back here in the public, in which you can keep all the assets for your project. So this is the image which I have given. You can put your logo, you can put your assets, and that's what you can simply attach. Close this one, come back to the style folder, in which you will find that we have this global.css. So we are using Tailwind in this particular project for styling and having the components. So this is the custom classes we have written. It's a very simple, which have some box sizing, decorative element, and we have the font and the padding. So this is the very simple setup we have for this particular project. So let's close this one, come back here, and we have to come back to our environment variable. So this one is very important. Here you have to provide your program ID. So once you will deploy the contract, you will get the program ID, means unique address for your contract on the chain, and that's what you have to provide here. And here you have to provide the address of your token, the token which you want to allow user to buy. We'll discuss about it. Okay, so this is the two variables which you have to provide in the environment variable. So let's close this one, come back to the get ignore, and here we have this regular models. Just keep it as it is, you don't need to make any changes. Now we have to come back here in the next config file, and there we have the basic configuration for our project. Just keep it as it is. Come back to the package.json file. So we are using the most stable version, and you will find that we are using the very trusted packages which is recommended by most of the Web3 provider for the Solana ecosystem. So you can see we are using the very stable version, and every single thing is working fine. So don't need to make any changes, no matter when you are building this project. As long as you follow this tutorial correctly and use the exact version which I am using, every single thing would be working fine. This is very important. You have to understand the architecture. So close this one. We have the post CSS. Don't need to make any changes. Just keep it as it is. Come back to the README file, and there you will find all the details about this particular project. You will find a couple of other projects which you can have a look. So check some important links you will find. So let's close this one. Come back to the Tailwind config file. Just keep it as it is. Don't need to make any changes. So close this one. So this is the complete folder and file structure we have in our project. I hope you have understood that how we have designed. So here you have two options. You can use the inbuilt package model right here in the VS Code, and then you can deploy the contract and do the comparison. So a lot of you will have the trouble for doing that. So I have taken another approach. So we're going to write the entire smart contract right up here. And once we're done with the entire smart contract, we're going to simply copy the contract, and we're going to use the Solana playground. We'll use the Solana playground. So I hope you are familiar with the Solana playground. You can simply open it, type Solana playground. You can simply search this on Google and then come back to this particular application, because there is a lot of fake Solana playground, and if you connect with the fake one, they're going to withdraw all the fund from your wallet. So you should always search on Google, come back here and try to create a project. So this is what we're going to use for deployment and compilation of our contract and generating the API. So here you will find, if you want to create a new project, you can click here, and from here you have this 3 framework. So you can go with the Rust native programming language. There we have to write a lot of code, but Anchor is a very powerful platform which has a lot of well-audited contract which you can implement in the contract to have all the functionality. So I'm going to pick Anchor in our project, and that's the most recommended one you will find, where you have to write less code, because the bigger your code is getting, the more amount you're going to pay for deployment of the contract. So we need to have the feature. So why not we can use Anchor, and Anchor is really powerful. Okay, so that's what we're going to use it. As of now, I'm just closing it up. So let's close it up. So I hope you have got the understanding that what exactly we have in the project and what are the tools and technology we're going to utilize it for developing our project. So now what we have to do is we can start working straight away on our smart contract. Now we can start working on our smart contract. So first we have to import the Anchor framework. So let's import that. Use is the keyword which we have to define if we want to import the packages. So we are calling Anchor lang and we want the entire package. So this particular model will give you the core functionality of Anchor framework, in which you will have three types. You will have the types, you will have the traits, and you will have the macros. I hope I'm pronouncing this correctly. So let's import that correctly. And that's how you can import the package. Now we have to import the Anchor framework for the token. So let's call this use, call this Anchor token, in which we have to import the models. So we have a couple of models. So we'll call this token. Let's define the self, and we have the mint function, we have the token function, and we have the token account function. So these are the model we need in the project. So let me repeat what we have imported. So first we have imported the Anchor lang. This will give me the core functionality of the Anchor framework, in which I have the three types. We have the three types. First one is the types, second one is the traits, and third one we have is the macro. That's the first package. The second package we have is for the SPL token, which will give you the entire SPL token program integration with the model, which we can utilize it, and in which we are taking the mint function, token function, and token account function. Very simple. Now we have to define the model. So what we can do, we can simply go ahead and we have to declare our program ID, because this program ID is the unique identification for our smart contract. So let's declare that. We'll call this declare ID, and in which we have to simply provide it. And by the way, we're going to use the Solana playground for deployment of the contract. So when we'll paste and compile the contract, this ID will be generated automatically. So let's call this program ID. So far, so clear. We got all of the basic model. Now we can come back here, and now we have to define the error, because we have to display the error in our smart contract if there is an overflow or if there is a wrong address getting called by different user. So let's define that. So it's a custom error which we can define. So let's call this error code. That's the model I want to div. Then I can come back here, and it's going to be a public, and I'm going to take the enum. So let's call this public enum, and I can call this structure name. So we'll call this error code, and it has similar structure. So before we write the complete logic of all of these functions, let's build the structure, build the skeleton. After that, we're going to start focusing one function at a time. So this is our error, custom error component. Now we can come back here, and we have to define our program. Now we have to define the program, and we'll take a public, we'll call this mode, and you can call whatever name you want to give your smart contract, but I call it ICO, and in which we're going to take all the state variable, all the function, all the struct, all the enum. That's all we're going to define it here. So what I will do, I'll simply come back here. This is what I have. And inside that, we're going to take a couple of state variable, because that's what is very important. We need three state variable. One is for the token address, which we're going to define in the contract. The second one is going to be the price of the token. And the third one is going to be our token decimal. So let's come back here. Let's take the first variable, and we are making a constant variable. Okay. So let's take this ICO mint address, and it's going to be a string type. And by the time I'm just giving it empty. Okay. Let's build the structure. After that, we're going to put our token address. And we'll talk about that which token model we are using, because right now we have two different token model, and we are using the most stable one, which you will find that 80% of the token you will have on the Solana blockchain will have the stable model, and that's model I'm going to follow. So that's our token model. Now this one is going to be the price. So I'll change with the UNT variable, and let's come back here, change this to per token, and let's call the price. So I want to decide the price of my token is going to be like 0.001. That's the price I'm going to set for one token. Got it? Let's replicate that and change this to decimal. I'm going to focus on the 9 decimal point. That's the most common decimal point you will find. And let's remove this and, because it's a UNT variable, not a string. And we can simply remove that one and call this 9 decimal point, because Solana has a 9 decimal, and that's what we are focusing. So this is the 3 state variable we have in our contract. Looks perfect. Now we can, this is good. So we have our state variable. Now we have to inherit the property, the packages we have imported. So we can do that very easily. So it's super easy. We can call this use super, and we can define the symbol. So in that way, what will happen, the packages we have defined, we can easily able to inherit in our contract to call those model. Perfect. Now we can come back here and let's write down the function. So the very first function we have to write, which help us to create the ATT, means our contract account in which we're going to transfer the token and all the details. So let's come back here. Let's take this pub func and we call this create ICO at. It's going to take a couple of argument, the context and the UNT variable. Just keep it as it is raw. Just build the layout. So this is the first function we have to develop. Let's write down the second function, which allows us to deposit more token into the contract. So let's call this deposit ICO in ATT. ATT stand for our contract account. In short, you can remember that. That's the second function. Now we have to write one more function which allows us to buy the token. We'll call this buy token and it will take a couple of arguments. So that's our three function we have. Very simple, but there's a lot of code we have to write in each one of this function to bring the functionality. So we have our ATT function which help us to initialize the contract and have a feature to deposit some initial token in the contract. The second function, the deposit one, will help us to deposit more token into the contract. Then we have the buy token function which allows us to buy the token. So we can come back here. Now we have to simply take the struct because we're going to store the data when the account will be created, when the transaction will happen. So we have to create the struct for that. So we can come back here. Let's take this accounts and here we have to define all of that. So let's take that one, call this struct and we can give the name. You can call whatever name you want. And this is the struct we have to define in the function. So we'll call this create ICO ATT and that's the struct we have. And let's call this info and we'll pass the empty object because in which we have to define the entire struct, that what are the data we want to store. So when we going to create and initialize that, then we have to store the information about the deposit, then we have to store the information about the admin, then we have to store about the account itself and the sheet fund. That's all we have to calculate. So this is the first one we have and we have to take a couple of more. So let's come back here, let's take another one and we'll call this accounts. This is a similar architecture, simply copy and paste here. And let's format this one and change this to be deposit because we have to initialize this when the token would be deposit. Simply copy that one and come back here and here we have to change this to, let's call buy token and it will be info and here we have to give the instruction. So let's call this instruction and this will be our ICO ATT for ICO program. Bam. And it's going to take our UNT variable when the transaction will happen because in that we have to pass the amount and the quantity. So let's take it and that's the entire struct. And I want to take one more where I can store the information about the admin, about how many token is there in the contract and how many token got sold. You can take more variables, but this is the standard. So we'll take the count and we'll define the struct, we'll make it public and we'll have the data in which we're going to define all of that. So as of now, just keep it as it is. So this is the entire structure we have for our smart contract. Now we have to go into deep and we have to write complete logic. So we have imported the packages from the anchor. We have our program ID, which we'll get. Here we have to write our custom error code. And here we have our state variable. And you will have all the function. So that's all the things we have to provide. Looks perfect. So currently the price of the token which I have set is 0.001 sol, but you can increase, just give 10 and it will be increase the price or decrease the price. Then we have this three function which we're going to write. This one will initialize our smart contract and create our contract address. Then we have the deposit and we have the buy and here we have the structs. Now we have to start with our error component. So altogether I'm going to have two type of error. One is the overflow and the other one is going to be for the admin. So let's come back here. First, we have to define the message, that what message we want to throw. So let's take this message and I can say that arithmetic overflow means if there is a overflow in the calculation, we have to throw this one. So we have this message. Now I have to simply define the hook. So we'll k overflow. Now all I have to do is to simply call this hook in the function whenever there is an overflow and it will throw this error message. That's the first one. Now let's take the another one for the admin. So let's call this, come back here. Let's take this message. And we'll say invalid admin, means if other user will call this particular function, we have to throw the error message. So we'll call this invalid admin. Perfect. This is our custom. You can take more, but we are making it simple and powerful. So this is our custom error. Now Looks every single thing is fine. This is good. Now we can come back here and let's define the price. So let's convert it to our, I hope I'm pronouncing this correctly. This is fine. Now I'm simply copy this one, paste here, and it's 9. So I'll simply give this 3 more 0. Looks perfect. So we are done with the state variable. We have inherited the packages. Now we have to work on the very first function, like initialize contract function. So in which we have to receive couple of arguments. So we have to build the context. We'll say context, in which we have to simply pass our create ICO ATT, the struct we have developed. So we'll take this and we can pass that. We'll call this ICO amount, because the user need to provide some amount to deposit in the contract so the user can buy it. You can simply remove this one, but it's ideal that you should initialize the contract with some fund. So it's going to be a UNT variable. Perfect. That's what we are initializing. Now we can simply come back here. And this is the same structure we're going to follow for every single function. Okay. Now we can come back here. Let's initialize it and call this result. And in which we have to simply pass. Now we are ready to write the complete logic. So there are a few things we have to do. So what we are doing, we are calling the functions. This is the name we have given. We are getting the context, getting our struct and the amount, and we are simply calling it. Perfect. Now we can come back here. Let's define our message. So first thing that we have to check for certain condition. So we have to throw this particular error message, like creating program ATT to hold ICO token. That's the message we have to throw, because the account will be created in this particular function after deploying and initializing the contract. That particular address will hold all the fund which we're going to transfer in the contract. So there is a two type of address. One address of the program which we're going to deploy, but this ATT account we have to create to store some of the information. Just keep it in that way. Okay. So that's the message we have. Now we can come back here. Let's do the conversion, because we have the price for per token and we are getting the ICO amount as an input deposit from here. So we have to do the conversion, and that's amount we have to pass down. So let's do that. So let's call this convert token decimal. So we can take a variable called raw amount, and we have a function called ICO amount. Like, it's not a function, we have the variable. Now on that we have to simply call this check mole. Mole stand for multiplication, in which we have to simply pass the token decimal. Then we have to simply call this okay if there is a success. Otherwise we're going to simply throw the error message if anything goes wrong. So we can simply pass our custom error model we have built, overflow, and it's going to trigger. So let's format this one properly. Perfect. This is what we have. Just write it as of now. When we're going to take this particular code to Solana Playground, where we're going to do all the formatting, it will automatically happen when you will save the code. Just focus on the smart contract and understand the logic. So this will give us the raw amount. So first we are converting the amount into a raw amount, which we can pass down to our program. So this is the first thing. Now we have to take one more variable. So let's come back here, come down. Let's take a variable called this. What I have done, I have taken a variable called CPI context, and what it is in the full form, cross program invocation. I hope you can remember this name. What it will do, that is going to create a context for calling another program. So let's write it code, then it will make more sense. So we can create the CIP context and we'll call this new. It's going to evoke and calling another contract. So it's very simple. We can call the account, and this account will come from our struct. So just building the function, but later will make sense. So let's complete that function. So we have the account in which we have the details. So we can take the token program on which we have to simply call the token account, like to account info. So this will give the information. Got it? In this way, what we are doing, we are calling the different contract to get the information. That's the first thing we have got. Now we can give this one, come back here. Let's take the another one. And now we have to use the token model. So what we have done, we have taken the cross program invocation model, which allows us to call the other function. And we already inherited the anchor framework token property, and that's what we are utilizing it. So call this transfer, in which we have to simply provide the details like from, to, and authority. So let's give the from is going to be my address because I'm the admin. So I'm going to initialize the CTO from admin, and I can simply provide the account info. The same thing we have to do. Now replicate this one, change this to 2, and this token will go to our contract. The ATT account we have created, we have to transfer to that. Let's remove it. Now we have to give the authority. So it's a account admin, and we can call this to account info. Very simple, not that complicated. It's a very simple logic. First we are converting it, then we are doing the transfer of the tokens. Now we can simply come back here and we can simply initialize it. We call this token transfer because we have the context in which we have to pass the where we want to do the transfer. So we have the CPI context and we have the raw amount. So it will transfer it. And now we have to check whether it's a success transaction or failed transaction. If there is a failed transaction, we have to throw the error message. We'll say transfer ICO token to program ATT and we'll give this one. If it's success, it will simply give me this. Now we can simply call here and take a variable and update our state variable. So we can take a variable call, let's say data, in which we have to update the deposit token and how many token got sold. That's the thing we have to update. So let's take this one, mute. We'll take the context, accounts, data, and that's what we have. Now we can simply come back here and we can simply call this data and update the details. So we'll say admin, and this function can only call by the admin. So that's why I have taken the admin variable and it will have the address of the admin. So we'll call the context and we can call the accounts, we'll call the admin and key. Then the next one we have to update is the token, total tokens. And this data we are already having because user are going to provide the ICO amount. Perfect. Now at the end we have to simply call this token sold is going to be 0 because when this contract will initialize, no one is going to buy. So we have to set the variable and we're going to display the message. We'll say initialized ICO data and we can call this success. Perfect. And this is the complete function we have, which allow us to create our ADD account, which will hold the token, and we are updating our local state data in the contract like token available, token sold, and other details, and doing the transfer of the token to the admin void address to the contract. So this is the one we are generating. Very simple, not that complicated. I try to keep the things simple. You can come with a lot of logics, build it more complex, but we are trying to do it simple. You can see we have the authority from the admin, and that's what we are simply calling and transferring it. We are throwing the error message once the transaction is successful. After the transaction, we are simply updating the data in our state management. This is the very first function for initializing the contract. Now we have to work on the second one, which is the deposit, and it's going to have the similar structure in which we have to simply deposit the token. So we already have the function in our create one. So let's take the context and we have to take our struct deposit ICO ATT, and we have to take the amount, that how much amount we want to deposit, and we'll take this UNT, similar structure, result. Now we can take this. Inside that we have to build a statement. So we have to check who exactly called this function because we don't want to allow other user can call the function. Only admin can call it. So we'll take the context. We already have the details in our struct. So we'll say data admin. If it's not equal to the one who's calling the function, then we have to throw the error message. We can simply return the error message we have developed. So we'll say error, we'll pass our error and pass the invalid add treatment. Perfect. This will throw the error message we have defined. Once it's okay, then we can simply copy this one, and that's the same thing we have to do. Simply copy that one, copy the entire portion, and that's what we have to paste here. We have to display, convert the amount, and then we have to simply deposit it. So it's going to have the similar same thing. So this is the same context we are simply doing the transaction and we have the authority. Now I need this information as well. Simply copy and this transfer model and paste here. So we have to transfer the token, and this is fine. Now change the function name to be deposit, and let's remove this one called additional ICO token. And this is up to you, that do you really want to add more additional token into the contract? Because generally what happened that we have to divide that how much supply we want to put for ICO, how much supply we want to put for airdrop and for the actual holding. So you can do at the time of starting, or you can simply fund more token later. There's no problem in that. So we can simply copy this one, actually copy this entire one, and that's what we have to paste here, cut and paste here. And here we have to simply remove few things. So remove this one. So we need the context of the data, of the struct one. That's what we have it. Now we have to simply do the update. So we have to update our total token because it will increase. So we have to do this plus and the deposit amount which user will provide. Perfect. And that's the only thing we have to do. And that's our complete function which allow us to deposit more token. Very simple, not that complicated. First we are checking the address who is calling this particular function, then we are converting that amount, then we are building the entire authority transformation. After that we are building the transfer model, and then we are simply updating our state. Very simple. Done with that, now we have to work on the buy function. So it's very simple. Same, we have to take the context, we have to take our struct, and we have to define that what we are receiving. So we're going to receive the details and the amount, let's say. So let's call this u8 unity variable, and we also need the token amount, that how many tokens user want to purchase exactly. You can do the calculation in the either in front end, or you can do in the back in the smart contracts, totally up to you. So let's take this one and call this result, and now we have to simply build the entire logic. So come back here, and we can simply come back here and we can get few things from here. So this is what we have. We need this conversion portion because we have to convert the amount, then we have to simply pass down to the transfer model, because the token would be transferred to the user, not the ad contract. So we can copy this portion, and then we have to build a lot of logic. So come back here and paste it, and this is absolutely fine. We are doing the conversion, and I can simply call this token amount to include decimal for SPL transfer, and this is raw input. Let's call this total amount, and we have this token amount, copy and paste here, and this is fine. Overflow, that's absolutely great. So this is the first thing, and we have to build one more condition here. Take another variable for the soul, because we are also transferring the fund to the admin account. So the user who will buy the token, he will give his soul, and that soul will go to the admin, and the token will come back to the user. So we can come back here. Let's take this one and remove this one, and we can take this, copy and paste, and we have to simply do the changes in the variable. So let's come back here. Let's give this command called calculation soul, and this is the price of our per token. All we have to do is to simply do the multiplication of the token. So we can have this, call this soul amount. Here we have all the things actually great. So we have the token decimal, and I can simply pass the lambda, because that's what we're going to simply perform the calculation. So let's provide that one. Per token price, we already have it. So this is the one, like this price for our token. And here we can come back here, and we already have the overflow, which is absolutely fine. So we have our token price and we have the error, because when we'll do the calculation and do the multiplication with the token price with the quantity, it's going to do the overflow. It can happen overflow or underflow, so that's the check we have to do. Now we can simply come back here, and we have to take another variable. Let's call this and build the transaction object. So let's take the context and our framework. We already have that anchor lang. We can have the Solana. From there we can take the program, and we can call the system instruction, because that's what we have defined, and we can call the transfer model. Perfect, very simple. What we are doing, we are using the anchor lang framework, in which we have the model Solana program. That's what we are initializing and calling the transfer model. Perfect. If you want to learn more about it, you can check the anchor documentation. So let's come back here, and we can take this context. We have the information about the user, because this user information we're going to define in our struct. So let's call this user. Key will be give the address, this will be admin, and this will remove this one and the soul amount, because that's the amount we have to do the transfer. Got it? Now we can come back here. Let's take this anchor lang. We can call the Solana program. We'll call the program invoke, in which we have to define. So when I define that object structure, then we can define our empty array, in which we have the entire model. So we'll take this context, account, user, token, account info, because that's how we can get it. We have to get the information about the admin as well, and that's what we have. Let's give this one, come back here, and we can display our message. So very simple. We can simply throw the error message or success message. Let's say transferred, and we call say lambda to admin this transfer token to the user. So we have transferred the fund. Now we have to do the transfer of the token. So it's very simple. I hope you guys have followed it. So we'll take the token address, and which we can get it from our context. So this is the mint token, and we can get the key. Once we have that, then we have to take the sheet, and in which we can define our mint address, and we can simply call this ref function, and we can simply initialize the program bump which perform it. Then we can simply come back here, take a variable called signature, and that's how we can identify that who is calling the function. So whoever will call the function, you can do the transfer with the help of the signature. You can take the address as an input field, and then you can perform the transaction. But when you will take the address as an input field and for performing the transaction, in that way there is a risk of failing the transaction of the gas fluctuation. Okay, so it's better to go with the signer thing, and this is the feature we already have in the contract, so we can take that. So come back here, take the sheets, and in which we can definitely provide it, and let's take this one. It's a variable. Okay, so far so good. Now we can come back here. Let's take a variable called CPI context. I hope you haven't forgot that what CPI stand for. It will allow you to simply interact with different contract. That's what it is. It's called cross program invocation. I hope I'm pronouncing this correctly. Now we can come back here. Let's take this context new, and the same thing we have to do, new with signer, and we have to provide all the details which we have done on top. So we'll take the token program, and we can simply call this account info. That's the first thing. Now we can come back here and take this one, copy, and that's what I can simply paste here because we have to transfer the fund. So that's good. And here I have to do the changes. So instead of admin, this time I have to do the transfer from the ATA account which we have initialized. So that's what we have to pass here, because this time the token is available in our ATA account. So that's what I got it. And 2 is going to be the user. So I'll say AT and for user, and this is also going to be from the for authority is going to be the program ID. So we can simply copy and paste here. Simple. So this time we are transferring the token from the account, from the initialized account, AT account, to the user, and call it. Perfect. Now we can simply call the signer and provide it. Once we're done with that, we can call this transfer. We can pass the details, the object and the amount. Once it will do the transfer, we have to simply update the status and the stats. So let's update our state context. So we'll take the data and we can simply update the information. So first one is going to be our token sold, and it will increase to the quantity. We'll say data. Then we have to simply update the token sold. Then we can update our check add, in which we can simply pass the token amount, and at the end we can simply go with this error if anything goes wrong and throw this one overflow. Perfect. And this is the entire contract we have. I hope you have understood. Now we can simply copy this one because we have to simply return a message, and let's give this one and change this to transfer token buyer and the quantity, and this is fine. So this is the huge contract we have. This is the huge function we have for allowing user to buy the token. So very simple. We have taken the information, and that's what we are simply updating. First we are updating the raw amount, then we are taking the soul, building the constraint, then we are calling the program to transfer the soul, then we are simply updating all this information and transferring the token. Perfect. Now we have to work on our struct. So we already completed the program, we already utilized this struct in our function, so it's very easy for us to simply define it. So let's define that very quickly. So you already know that what are the variables we're going to keep into each one of these structs. So let's do that very quickly. So come back here. First we're going to take the account, and in which we have to define that. So first is going to be the init, then we'll take the pair, and we already have the admin, because when this account will be created, who going to call that particular account? Admin. So admin is the pair. Then we have to take the seed admin's address, and it's coming from ICO mint address parsed. There we can simply call the public key, and we can call this unwrap as ref. Got it? Now we can come back here, take the bump, and we'll take the token, we'll pass the mint, and we already have the token mint address, and we can simply pass the authority to be the account which we have generated. So we'll say this one, ATT for ICO program. This is the account we're going to generate, and that's what we going to attach as an authority. Perfect. That's the first thing. Perfect. Now we can come back here. Let's take a public, and let's define this ICO ATT for ICO program. We can call this account, in which we have to define. So we have to define the info. So let's define that, and you can add more details. So first one is going to be info, second one is going to be token account, because when the transaction will happen, there is account would be created in the model. So we have to initialize that in the info account. Perfect. That's the first one. Now we can simply take the another one. It will be account. We can say init pair admin, and we can take the space 9. I'm going to with a maximum rate, but you can play around with this value, but this one is the normal one which mostly execute your transaction. And we'll take the seeds. In that we can simply define, we already have that detailed data, and we'll pass the admin key, and we can simply use the model to have the access. Very simple. Then we have to build the public one. We'll say data account is going to be info, and we have the data. Perfect. That's the second one. Now we can take the third one. Same logic we have to apply. We'll take this address. We're going to simply go with the ICO mint address and call this parse, in which we have to simply call the public key, and we can call this unwrap. That's the third one. Now we can take the another one, account mute. Then we can define this ICO ATT for admin account. We'll say info token account. Now we can come back here, take another one. We'll call this mute, and this will be public. Admin is going to be the signer. When this particular function getting called, it's going to call by the signer admin. So we'll say signer. We'll pass the info, and perfect. Now we can come back here. Let's take a public. We'll say system program, and we have the program in which we can define the info and the system. Let's replicate this, change this to our token. This will be token, and this one is going to be our rent. This will be sameware, and this will be rent. Perfect. And that's the entire struct we have for our initialized function. So we are getting all of these details. We are passing all to the models, and looks absolutely fine. I want you to pause the video and try to understand. Got it? Now we have to work on the next one, which is the deposit one. It's going to have a similar structure, because in which we have to simply focus on the deposit. So let's take that very quickly. We'll take the account, and we'll take the mute public. We'll call the account program, in which we can pass the info and the token account. Simple. Same thing. Then we can simply copy, paste here, and this will be our data. This will be our data. Now we can come back here, take an account, and we have to initialize that. So we'll take this ICO mint address. It's going to be a parse, call public key, unwrap. Now we can come back here, take a public ICO mint account, and call info mint, and this is fine. We have the mint. Perfect. Now we can take this account mint, and we'll take the public ICO admin and call this info token account, because this function is only called by the admin. That's the reference we have to give to our account. You can go with the hardcode one, but it's not important. You should always go with the dynamic approach. Perfect. Now we can simply come back here. Let's take the count, and we can define our variable admin. We'll say signer, because this function will be called by the admin, and the last one is going to be the token program. Pass it info token, and perfect. Now this is our deposit struct. So all of this variable is exactly the same, just we have removed the ATT one. Now we have to work on the buy one. This one is going to be a little lengthy, because we have to keep the things in mind for the buying, as well as the transfer of the token or initializing of the account. So we can come back here. Let's take the account, in which we have to define. So mute, this will be our sheets, and this will be the dynamic one. So we'll take this ICO mint key, in which we have to call the model, and then we can simply take the another one, bump. We'll say ICO ATT from ICO program bump, and we can take a public. Let's define that one, ATT program, because when the buying will happen, the fund will go from the contract, the account. And let's define that account info, and it will be token account. So what I hope you have understood what happened here. Now we have to take another one. We'll say public data account info data. Let's come back here, take an account, in which we have to do the same checks. We'll say address equal to the mint address parse, and we can call the public key, unwrap. Then we can take this ICO mint account info, and we'll take the mint. Come back here, we'll take the account mint public ICO ATT for user, because we have to initialize details about the user, because we are transferring the token to the user vault address. So let's do that. We'll take this account info, and we have the token account. Got it? Now we can come back here. Let's take another one, call this mute. User is going to be the signer, because this time user will call the function and is going to pay the fund. So signer will call this info. Come back here, let's check, call account, then we'll take this admin, account info will be info, and we can come back here, we'll say token program, in which we have to pass the info and the token. This will be our system, this will be our system, and that's the entire thing we have. I hope you have understood that what we have done. Looks fine. Let me have a look. So this is what we have. We have initialized, this is what we got it, and we have all the variables about the system, about the user, about the admin, and about the contract ATT account as well. So the last one is very simple. Can you guess what are the things we can keep? So it's a simple struct. Only 3 information we have to keep here. So let's write it down very quickly. So first one is going to be the admin. Second one is going to be the total tokens. And the third one is going to be our sold token, how many token we have sold. And that's the entire smart contract we have written. I hope you have understood. It looks simple, but it's really powerful. Tons of things are happening, and we have written all of this logic. So this is our state variable, this is the functions, and this is the deposit function we have, this is the buy function, and here we have the struct for the initialization, we have the deposit, we have the buy one, and here we have the state for admin, token, available, and sold. So that's the contract. So finally the contract is completed, and that's the only thing I want to cover in this video. In the next video, we're going to start taking this contract to our Solana playground. There we're going to do the deployment, optimization, and after that we're going to start working on our front end. So let's move to the next video. Welcome back to the second part of our project. In the last part, we have completed the entire setup and we have written the complete smart contract. Now we're going to do a little bit optimization and fix a couple of bugs. After that, we're going to start deploying the contract. So this is where we left in the last video. I hope you guys have followed it. If not, make sure to watch the last video. Every single thing would make sense. So this is absolutely fine. We have the error component, and here we have to put our token address, which we're going to discuss in detail. Here you will find the entire context management, and here you have to add few things. So you can see I have added this particular command. So make sure you have added this semicolon, otherwise it's going to fail the compilation. So this is the first thing you have to add. Make sure you have to add your semicolon. After that, you can come back here, and here you have to also add the question mark and the semicolon so it can execute. So that's what I have given. So make sure you should add this one. Now you can come back here, and here you have to initialize and add the space. That's the one thing. Now you can simply come back here, and I notice one problem here. So here you can see that we are generating our ICO for ICO program. So you should remove this one. You should remove this one. You should not have this one. Okay. So this is the one actual one we have to add it. So I have simply removed this portion, and that's what you have done. So make sure to do this particular update, otherwise the compilation will fail. So this is the update you have to do here, and you have to also add the semicolon right up here. So I hope you are following this. So make sure to provide this semicolon. This is absolutely fine. Now you can come back here and check this all. Looks absolutely fine. No problem we have here. Now we can come back to the next function, to the deposit one. This looks great. And you can see here we have to add this question and the semicolon. And again, we have to do the changes right up here. You can simply provide this space or not. It's absolutely fine. But make sure you have to remove this one. So here I have the 2, and I have taken the updated one, in which I have removed this space. That's the one thing you have to remove. And here you have to also provide the semicolon. And this is fine. And these are fine. Now you can come back here, and you can see here we have to again provide this one, semicolon and the question mark. Here we have to also add the semicolon and the question mark, and here we have to add the semicolon. Looks fine. Now we can come back here. Every single thing is good, and here we have to do the changes where we are transferring the token from the program to the user. So again, you have to remove this from the from. I have removed that. If you come back to 2, it's absolutely fine. But when you come to authority, then you have to remove this one. Remove this one and have a normal one. Got it? Make sure to provide the semicolon. Looks fine. And here we have all of this codes. Don't need to make any changes. Now you can come back to the struct, and you have noticed that I made this mistake. So it was a spelling mistake. It's called PARSE, parse, not D. So remove that one. That's the one thing you have to remove. And you can simply come back here, and here you can simply provide a little bit space. It would be better. Okay, that's what I have done. Provide this space. And we have the bum, we have the mint, We have the program, which is absolutely fine. This is also good, don't need to make any changes. And here we have the account details about the pair, absolutely fine, don't need to make any changes. Here we have this, so we have the account, mint, address, and the public key. And here you have to add this particular line, so I forgot to add this one. So you have to add this pub, then you have to give the variable name and the account and information about the mint. So this will give us the information about the token. So this is the line. In your case it would be missing, so make sure to add this one under your create ICO token below our mint address. Got it? This is the line you have to add. Once you're done with that, now this is fine, don't need to make any changes, and this is absolutely fine. Now you can come back to the next struct, and this is good, don't need to make any changes. Here we have all the variable which we need. Now you can come back to the last one, which is the buy one, and here you have noticed one thing, that we have to add the space, so that's what I have given. You have to add the space, and which we have added, and here you have to simply add the key. So earlier I was taking like the dash notation, but you have to access the variable, and that variable we have available in the ICO mint. So that's what we are asking. So make sure to access in this way, not in this way, otherwise it's going to throw an error. So this is the changes you have to do. You have to add this, and you have to give a space. Looks fine. Now you can come back here, this is absolutely fine, and this is good, don't need to make any changes. Here we have all of this, this one is great, and we have all of this, and we have all of this. So I hope you have followed it. Make sure to pause the video and compare your code one by one, that you exactly have the same code. So every single thing is looking good. Now we are ready to start deploying our contract and doing the compilation. So before we do that, I want to talk about one important thing. Right now we have two different Solana token model at the moment on the Solana blockchain. So make sure you have to put the stable version. So if I come back here, if I go back to the public, there you will find an image, click on this, and right now we are following the most stable version. So make sure to use the stable version, and I believe that if you have created a token, you have used the program, the tools for creating the token, they have used the stable version as well. So you can simply come back here. If you don't have the token, you can simply go back to the blockchain coder, and there we have a lot of tools which you can use to create your token. So come back to the source code section, and here you can simply type Solana, and you will find all the project which is available, which you can able to explore and create the token. So this project you can follow, it's a 5-hour long project in which you can build your custom token using the stable model, which we're going to use it in this particular project. You can also check this particular project. This one is the token creator, we have this one is the advanced token creator. We have these two different advanced creators which allow you to earn the commission when the user will create the token. So you can use all of this project to create a token, and we are following the stable model. That's the point number one. And if I open my Phantom wallet, you will find that I have already created bunch of token which use the stable version. So right now I'm connected with the Devnet, and if you come back here I have the list of all the token which I have created. So just wait, it's taking a little bit time for fetching that, and here you will find the balance I have in my wallet is good. I can click on it, I can click on the manage, and then you will find the list of the token which I have created using the stable model. So make sure you should have your token, and most of the provider which you have used for creating your token, they have used the stable version, and that's what I'm going to utilize it. So make sure to get your token address, and that's what you have to pay. So I'll simply come back here. I'm going to use the account number 1 for deploying the contract. If I come back to account number 2, do I have fund? I don't have enough fund, but I'm going to use this particular contract address. So you can simply come back here, and you can see this is the one which I'm going to use, and I have used the account number 1 to create this particular token. So I can simply come back here, I can simply go back to the mint address, I can simply copy that one, and that's what I'm going to provide here in my contract. So this is my token contract address. Now we are ready to deploy. I hope you have understood the entire architecture, that what model we are following and what are the changes you have to do in the contract and fix those minor bugs. With that, we are done with this. Now we're going to simply copy this entire code and paste it in a Solana playground. So make sure to select the entire code. Now you can come back here, open a new tab and type Solana Playground. You should always search on Google and then come back to this particular application, because right now there is a lot of fake Solana Playground is there. If you connect with the fake one and they go to withdraw all the funds. So I'm going to connect with the account number 1 because that's the account I'm going to use for deployment for my contract. And you can see here I have all the things. So I can simply come back here and go back to the manage one, and I'm going to search for the token. So not this one. I'll simply come back here in my contract, and first I'm going to search from here, copy the address, and that's what I can simply paste here, and I can see I have the fund. If you really want to see which token it is, you can simply get that, And you can do one thing, you can simply open that and you can search for Solana Explorer. You can come back here, you can simply go and go to the Solana Explorer and you can find the details about the tokens. Right now I'm connected with the mainnet. I will simply switch to the devnet and there I have the detail. I can paste here and hit enter, and it's going to get me the information about the token, that who is the admin, who is the creator. That's all the details which you will find. So here you will find the details about the token. So this is the token address and this is the creator, which is the same account GNF, and you will find that I have the same account which is a GNF. So that's what I'm using. I hope this is how you can explore your token detail, and that's what I have provided. Now I'm going to come back here. I'm going to simply copy my entire code once again and then come back here in the Solana playground, and I'm going to create a new project. So let's delete this one existing one and we can come back here. Here we have the fresh repository. I'll simply click on this create and it's going to give me this option. So I'm picking the anchor framework. I'll say Solana ICO DApp. You can give whatever name you want. I click on this create and here you will have the repository and they will give you this boilerplate. Simply ignore that one, select all, remove and paste your contract. Now you can save it and here you will find all the things. So you can find that our contract is properly well formatted. Now we are ready to simply compile it. So to compile our contract, and if there is a problem in a contract, it's going to throw it. So I can simply come back here and here you will have the option called build. So click on this build and when you will click on that, it's going to generate the program ID automatically. So click on build and there you will find that we are using the package. This is the GitHub repository. You can use internally in your VS Code, but it's good. Why we should take extra burden for installing and doing the setup for the environment? You can do that, there is no problem it. But there's a lot of setup you have to do, a lot of environment variable you have to set up in the global object. Then you can able to have the access of this particular model. So just keep it as it is, and you can see our contract got compiled successfully. We have no issue, and once the contract will get compiled successfully, it will automatically going to fill out your program ID. This is the program ID, and you can see that right now I'm not connected with my Frontend wallet. So I'll simply click here and it's going to connect. So what I will do, I'll simply come back here, and right now I'm having some issue. I'll simply give a reload to connect my wallet. So here I got the option, I can click here and I'm going to use the same account. This is the account which I have used. If I show you my Phantom wallet, I have used the account number 1 for creating my token, and I have to use the same account for deploying this particular contract. Then in that way we can able to share the authority and pass the token to our contract. This one is very important. You have to use the same account which you have used for creating the token for deploying this particular contract as well. So I already have enough fund. If you don't have enough fund, you can simply come back here and you can simply click on this airdrop and it's going to make a request and will give you some fund in your wallet. So here I got the fund in my wallet, which is enough for me to deploy the contract. So before I do the deployment, let me reload the page one more time and you can see every single thing is looking good. Let's come back here. Let's run the build command one more time and it's going to compile the contract. So just wait. Once it will compile, we are ready to make the deployment. Finally, our contract is compiled. Now we are ready to deploy our contract. So click on this deploy and it's going to make a call and it will open our front-end wallet and we have to perform 2 transactions and deploy the contract. So just wait. So you're getting this warning, simply ignore that one. Click on this confirm and here you will get it one more time. Click on this confirm and here the transaction is in the process. So I think we are having some issue in our RPC endpoint. That's why the transaction is not executing and you can see we are getting simulation error. Not a big deal. We can simply close this one as the moment and let's have a look to our RPC endpoint. So we can come back to the setting and there you will find all the details about the transaction which we are trying to make it. So let's close this one. I don't want to execute it anymore, and you will find that we have all of this information. Right now we are connected with the devnet. If you click here, from here you can able to toggle between all the environment, like you can go with the localhost, you can go with the devnet, testnet, mainnet and custom. So if you want to add the custom endpoints, you can simply click here and you can provide and you can give the name. If you want to deploy to the mainnet, you can do that, but this particular endpoint, like if you select mainnet and if you try to execute the transaction, it will not happen because the RPC endpoint they have used is depreciated. So this RPC endpoint will no longer be working. So you have to come back here and you can able to find, explore all of the details, and you can easily able to do the customization from here and put your details. So this is one is really very important and very basic. So I would suggest you that when you want to add the custom endpoint, change the RPC endpoint, you can simply click here custom and you can give the name, or you can share the mainnet RPC URL and you can call it. Okay, you can click here and they will have a bunch of provider which you can use it, and how you can do the configuration. That's all is explained. You can use Anchor, like you can use Acme, you can use Infura, you can use like ARKM, tons of provider we have. All you have to do is to provide the RPC one. Let's focus on this first. So I'll simply come back here and I'm going to delete this. Let's remove this one and let's open the playground one more time, because sometimes what happens is keep the history of the previous account. So here I got it and every single thing is looking good. I can see that I have the fund. So somehow the connection got lost. So as I told you that this problem is happening due to our RPC endpoint. So let's click here and I have to select the, let's say, Devnet, and it's going to fetch out the balance. You can see I have the balance. Now I'm going to simply get to the default. So this one is the default wallet which you will have in your Solana playground. So I'll simply select this one and I have enough fund in that. So I can simply come back here, click on the, let's click on this, and I can switch my account first and I have to copy my address. So I'll simply click here, copy the address, and you can also get the fund in this way. Like you can come back to the default wallet which you have in the playground and you can simply click and you can send to your main one. So I can simply transfer, let's say 15 SOL, and click on this transfer and it will perform the transaction. So this is one way to get the fund, because every time you will open the Solana playground, a playground, it's going to make a request to the default wallet which you will have in your Solana playground and it's going to add the fund in that. So you can simply get it. So if you come back here to your main account, you will have enough fund in it. Got it? Let's come back here. Let's open it one more. Solana playground. Now here we are. Now let's do one thing. Let's create a fresh repo, because sometimes it's created the issue by the repo. Type Solana ICO DApp and pick the anchor framework and create the repo. So here we got it. Now I can come back here. This is the entire contract. I can simply copy. Now I can come back here, remove and paste here, save it, click on this build, and it's going to rebuild our contract and it's going to compile it and it's going to give the ideal file. So just wait, soon it will be completed and we are ready to deploy our contract. So I can come back here, I can see which wallet I'm connected, so I will switch back to my actual wallet. So just wait, it's taking a little bit time, and finally it's went through. I'll simply click here and I've noticed one thing, that I have not connected my wallet. So I'll simply close this one, and first I'm going to see what happened to my Phantom wallet, and I do have enough fund in this for performing the transaction. So let's click here, and why my wallet is not reflecting here. So first thing, I have to simply click on this connect to Phantom wallet and you will find that I'm connected and all the fund is relating fine. So I'll simply select here, click on this build, and it's going to compile my contract. Just give some moment, and finally our contract is compiled. It looks pretty good. Now I can click on this deploy and it's going to perform the transaction. So just a moment, we are getting this. Simply click on this confirm. We are getting the network fee and it's going to make the transaction, executing the transaction. Just wait, and it's going to execute one more transaction, and here we got it. And the reason why we are getting this, because sometime it's a devnet, sometime it failed to stimulate the transaction. Okay, so you can click here and you will find that our contract is deployed successfully and you will have all the details. Sometime you will get this particular message because I have used it a lot of time and I made a lot of requests, so it's failed to stimulate the transaction, but our contract is deployed successfully. You can see the signature, all the details, all the contract interaction, all the block model. That's all you can able to find. Here you have the program ID and our program is successfully deployed. So we got our contract. Now we can come back here and I want you to simply copy the code, whatever you have pasted, and the same code you have to bring it here. So it's in the well formatted. Perfect. Now we have deployed our contract and we got all the details. Now we have to get some details about the program ID. So this is the program ID which you can get it from here, or you can simply copy from here. So you can simply come back here, copy, and that's what you have to paste. So close this one. Right now we are done with this. Close this one, come back here. Now you can go back. So now you can go back to environment variable and here you have to paste that particular program ID. So this is your program ID. Now we have to get the contract, like the token address, and we have deployed this one token. So I'll simply copy, and that's what I'm going to paste here. So this is the two environment variables we have got. Now we have to get our API, because right now you will find the idle file is empty. So I can do that very easily. I can come back here and I can simply call this export model, and here we have the API. So I'll simply come back to my code editor. I'm going to do the minimize a little bit, click here, and you will find that here I have the idle file which we have got for our contract. So you can simply save it and you can simply copy the entire code, and that's what you can simply provide here. Or you can simply drag and drop, and it's going to remove the previous one. You can replace and it will be removed, and here you got your idle file. So this is the first thing we have to do. So we have successfully deployed our contract, and this is the contract we have deployed, and successfully we have compiled our contract and got the ABI. It looks fine. Now we can start working on our front end, where we have to work on our context management here, and we have to work on our index page. So let's start working these two in the next video. Hey everyone, welcome back to the third part of our Solana ICO DApp project. This is where we left in the last video, and now we're going to start working straight away from here. So let's come back here, and this is our app.js. Here we have to build our context management and do all the configuration for the wallet. So what we can do, close this one. Now you can come back to the package.json file, and let's install all the packages. So you will find that we are using the latest and the updated version of the packages, and this is the packages which you will find in most of the decentralized application for the Solanas, which is really powerful. So no matter when you are developing, as long as you use the exact version, every single thing will be working fine. So now open up your terminal, and if I check my node version, you will see that I have the latest one. So there is no problem with this node version. Now let's do the installation, and just wait. It depends that how fast your internet connect is and how good your operating system is. So you can see in my case the installation got completed very quickly, and you will find that I'm getting couple of warnings and couple of vulnerabilities. Simply ignore that. It's not that important, because we are focusing on stability and using the combination of old and new packages. So this is fine. Don't execute any one of these command, otherwise it will change the package version and it will create an issue. So let's clear the terminal. Once we have the installation, now we can start the application. Type npm run dev, and it's going to start. This is the command we are executing, and here we have the local. Simply copy, and that's what we have to simply minimize all of this. Close this one, open a new tab and paste here, and you will find that our application is looking absolutely fine and started, and we have this index. Perfect. Now we can come back here and we can start working on our app.js first. So this is the one where we have to do all the configuration. So let's do it quickly. And first thing, we have to import the packages. So we're going to import, and this is coming from Solana wallet adapter, in which we have to get our wallet adapter network. Then we have to import our Solana adapter React. From there we need the connection we need the wallet provider. So this is the two we need: connection provider and wallet provider. Now we can come back here. We have to get our Solana wallet adapter React UI, so it can display the pop-up, and we can get the model. Now we can simply import the Solana wallets. So I'm going to display two wallets, Phantom wallet and another wallet, SoFat. So let's import Phantom. Then we have this. So we got the wallet. Now we can come back here and we have to import few things from Solana Web3.js. There we need the clustered, in which you will have all the network like mainnet, testnet, devnet. That's what we can pass it. So it's absolutely fine for the devnet, but when you want to do the configuration for the mainnet, we have to put our custom RPC endpoint. So let's import that. We have the API URL. Now we can simply come here and let's import the React, in which we need the use memo, because when there is a change in the network RPC endpoint, we have to trigger the event. Then we can come back here, and I can see that I'm missing something. I have to import the CSS file. So come back here. We'll take this Solana React UI, and there I have to simply get the CSS file, because when the pop-up model will open for the wallet, we have to add the CSS file for the package, and that's what we got it. Now looks fine. We can simply come back here, and here we have to simply take a variable and do the network. So I'm going to do the configuration for the devnet. So let's do that. We'll say wallet adapter network, and from there we can able to access the network. So we will have the mainnet, devnet and the testnet. So let's access the devnet, and this is how you can access. If you do the console log of this wallet adapter node, you will find we have three different network, which we'll see. Perfect. Now we can come back here, and that's the configuration we have to do. So let's take this endpoint, in which we can take this use memo. It will take a callback, and then we can call our cluster, in which we can pass the network. Perfect. This is the endpoint which we have to pass into our context. So let's come back here. Let's take a wallets, and there I'm going to define all the wallet which I want to take. So it's going to be a Phantom wallet, and we're going to have the second wallet. So replicate this one, copy, and that's what we can paste here. So far so good. Now I want to trigger this event when there is a change in the network. We got the network. Now we can start working on our JSX, and let's do the configuration. So first we have to take our connection provider. Let's close that one. Inside that we have to pass the prop as a endpoint. Then we can take this, let's close that one, and inside that we're going to take the wallet, and we're going to simply pass our wallets, and it will be have a auto connection. Let's cut this one and bring it inside this wallet provider. Perfect. So this is the first configuration we have. Now we can come back here. Let's take this wallet model provider. Let's close this one and close this one. So this is the entire configuration we have here in .appjs file. So we have done the configuration for the network, and we have wrapped the context. So that looks fine. We got the packages, looks good. We got the network, and here we have it. Now we can come back here and reload the page. Right now you can see I'm getting some sort of warning. Okay, so let's reload the page, and every single thing is good. This is what I have. I can simply reload one more time, and you will find that there is a problem in our wallet adapter which we have imported. So phantom wallet is good. The second wallet is creating the problem. So let's come back here and let me have a look in the spelling. Okay, this is the problem. It's a SOLFAFL. Okay, the L was missing. Simply copy and paste here as well and correct the spelling, and now it's good. Perfect. Now it's good. Now we are done with this. Now we can start working on our index file. So let's have a look. Perfect. Let's start working on this. So what I'm going to do, I'm going to simply import all the packages, and I'm going to build the main functionality which allows us to communicate with the contract and have the connection. After that we're going to start working on the JS. So let's work on the main functionality. So first thing, we have to simply import few things from React: state and effect. Then we have to import the dynamic import, and this one is very important because the wallet provider which we are using, it will throw a hydration error if you use and import it straight away. So it's important that we have to manage it dynamically because there is a little bit delay in the connection, so we have to handle that. That's why I'm using the dynamic package. It will make sense, just follow along with me. Then we have to simply do the import for the, let's say, Solana wallet adapter React, in which we need the use wallet and use connection. These are the two model. Then we have to import from Solana Web3.js, and there we need few things. So we can come back here. We'll take the public key. We'll take the system program. We'll take this SYSVR, and the next one is going to be transaction. So this is the four models we are using from this particular package. Now we can come back here. Let's import our next one, which is coming from Solana SPL token, and then we need details about the model. So we'll need the token program ID, then get associated token address. So we'll pass the detail, and it's going to give you the details about the user who connected with the application and in respect of the token. Then we can create associated token account instruction, and this one is a really powerful platform because in our biome function we have a feature which will create the association related to the user account in that particular token. So this model will use it. So this is the one we have. Now we have to create this get account. So this is the package we have. Looks fine. Okay, now we can come back here. Let's import the idle file, our AB of the contract, and that's coming from our idle JSON. So if you come back here, if you go back to the library in which you will have the file, so that's what we are importing. Perfect. Now close this one. Now we can come back here and we can take the dynamic import of our wallet connect. So we'll take this wallet multi button, and we'll take this dynamic model, the package, and it's going to take a callback function. There we have to simply import. So let's call this the wallet model, wallet adapter React UI, and we'll pass the catch the synchronous. So we'll take this mode, and we'll take the mode dot wallet multi button, and that we can simply pass this. We can pass the property called SSR false, and that's our dynamic button. All we have to do is to simply import the wallet multi button in our component, and we'll have the button, and we'll reload the component behind the scene. So this is the one, we have it. Now we can come back here. Let's take the environment variable for our program ID, and that's coming from our environment variable. So we can come back here, and I'm going to simply copy this one, and that's what I'm going to paste here. Replicate this and come back here, copy this one, the token address, and paste here. and I'm going to simply copy the name, and that's what I'm going to provide here. Perfect. This is the environment variable we have. Now we can come back here. Let's take a variable called program id, and in which we can use and pass to our public key. So we'll say new public key, in which we can pass our program id and the token id. So this is the variables will have the proper formatting of the addresses, which we can pass down to our contract. Now we have to take the token decimal, and we already have the package called bn, in which we can pass the token decimal, which is the 9 decimal point. So this is all the variables we have. Now we can start working on the body. So let's have a look one more time. We have all the packages. This looks good, dynamic button and the environment variable. Now we can come back here and let's quickly take a couple of state variable which we need, like amount, loading. So let's take that one. So first is going to be going to be a normal function. So I'm going to simply convert into a default function. So let's copy this one and remove this portion and call this function home, and that's what we have. Let's take a state variable, call this loading. By default it will be false. Then we'll have the is admin false. Then we'll have ICO data null. Then we'll have amount, it will be empty. The second one will have the user token balance. By default it will be null. So these are the state variable we have. Now we have to inherit the connection and the wallet details from the package. So we can come back here and we can take this, call use connection, replicate this one, and this will be use wallet. So from the use connection we need the connection, and here we need the wallet directly. So let's remove this one and call this wallet. Perfect. So this is the states we have. Looks perfect. Now we can come back here and let's build a use effect hook. So when the page will reload, we have to call a couple of functions. First we have to check the user connection, second we have to check the admin, and third we have to fetch the balance. So we can come back here and we can do one thing. We can simply take the use effect and let's build the function hook first. So we'll take this if connection is there, means the wallet address, the wallet is connected with the application. So that's the first thing we have to check. Only then we have to call this three function. We'll say check if admin, the second fetch ICO data, and the third one is the user token balance. So these are the three functions we're going to create which fetch the details about the user and the contract. And I want to execute this whenever there is a change in the wallet. So let's call this here. We'll call this wallet connect. Perfect. So this is the hook which will fetch the balance. Now we can come back here. Looks perfect. And let's comment this for time being. And now we have to build our first function called get program, and this will create and give us the provider, and it will help us to communicate with the smart contract. So we'll say if wallet connect is not there, then we have to return nothing, else we have to go with the provider. So we already have the details. We'll use the anchor framework right up here. There's a new anchor provider in which we have to pass the connection, we have to pass the wallet, and right now you will see that we don't have the anchor framework, so we have to import that. So we can come back here and let's import the packages. So this is the one we have to import. Come back here, let's call this anchor, and it's coming from our program. So we'll say program coming from our project anchor. So let's import that one, and let's import the program anchor provider web3 and bn, and that's the packages we are using, and this is fine. Let's see, are we missing anything? No, so far things are looking good. Now we can come back here and let's bring back this function and let's start working on it. So we got our provider and we already have that one. Now we can simply come back here and pass the details. So let's pass the connection is going to be confirmed. Now we have to return. So we'll say new program in which we have to pass the idle file. Then we have to pass the program ID and the provider, and it's going to give us the details about the program which we can call it and use the model. So looks fine, every single thing is good. So this is the main function which deal with the contract interactions. Perfect. Now we have to work on the next function, and this function will allow us to simply check the admin, whether the admin is connected or not. So that's the check we're going to do, is because admin will have certain feature like initialize contract, withdraw token, deposit tokens. So we have to make the check for the admin. So let's come back here. We'll take the try and catch, and in that we're going to simply console log out the error if there is an error. Now we can come back here. First we have to get the provider. So we'll first check the provider, and that's coming from our function. We'll say if provider exists, then we want to continue, otherwise we want to return like nothing. Then provider we have it, then we have to simply deal with actual functionality, and we'll take this data PDA and we'll say await public key. We'll use the find model and we can simply pass the details. So we'll pass the buffer from in which we can pass the data, and we have the void address of the user who connected with application key, and we have to convert it into a buffer. Perfect. And we'll pass the program, and we already have on the model called program ID, and that's will give us the details. Now we can come back here and we'll take another try and catch, and here we have to simply do a little bit check. So first let's console log out the error if anything goes wrong. We'll say checking admin and the error. Then we can simply come back here and set the error admin to false, means it's not the admin. Now we can come back here and we can take the models. We'll take this data await program account data, will fetch, and we'll pass the data PDA. So it's a capital P, so let's make it capital P, copy, and that's what we have, the information about the wallet corrected. Now we can come back here and we can simply set that to an admin, so it can return either true and false. So we can come back here and let's get the data. So we'll say data admin equals wallet public key, and it will return either true means it's admin, false means it's user. And that's the only thing we have to do here. Looks fine, and let's format it properly. So let's bring that here and we can come back here, and here we're going to go with the default one. So let's make it this accounts program account data all. Once we have the complete wallet, because in the wallet there is a multiple address, user can have more than one address, so we have to check the length for that. Let's say account.length, and we'll say if it's equal to 0, then we have to simply set this to true, else we can go with the false, and we can simply set the data to be the account first, and that we can get the accounts. Simple, not that complicated. Hope you have understood. First we have got the program details, then we have got the details about the wallet, then we are doing all the check and setting the state variable. Perfect. So this is done. Now we have to work on the fetch ICO data and fetch user token balance. So let's go close this one and close this one, come back here. Let's take the fetch ICO data, and this is the one we have to get, which will deal with fetching the balance or details about the contract. So we can come back here, we'll take this async, we'll have a try and catch, and first we have to check the program. So we already have it here, so we can simply copy it, and that's what we can paste. So that's the first check. Now we have to simply come back here and we have to take a variable called accounts await program accounts data all, and then we have to check the length. If it's greater than 0, then we have to simply set the ICO data to be the accounts and first, and from there we can access that account. Very simple. Now we can come back here, we'll catch the error fetching ICO data, and that's what we have. So all we are doing, we are checking for the connection, then we are fetching the details about the contract, means all the information, and that's what we are setting to our state management. Perfect. Got it? And that's our function is ready. Fetch ICO data is ready. Now this is fine, this is fine. So now we have to work on our initialize contract, because this function is very important, in which we have to simply initialize the contract as well as we have to deposit couple of tokens in the contract. So let's do that. So let's come back here, call this create ICO ATT, and it's going to be an async function, similar structure we are following. Let's take the try and catch block. And so first thing we have to check the amount, because we have to pass the amount, the token quantity into the contract. So we'll say if amount is not there, else parse int amount then is less or equal to 0, then we have to simply throw an alert message that please enter a valid amount. That's the first check for the quantity, because user need to deposit few tokens in the contract. That's the first one. Now we can come back here, let's set this loading to true, then we can simply check the program, and we already have the function. Once we have the program, we have to check whether it's available or not. If not, then we have to return an empty. And we can come back here, we'll take this and let's build the structure. So first we have to create the entity and then we have to do the transfer. So let's call this ICO ATA PDA is going to be wait. We'll use this public find program address in which we have to pass all the details. So first is going to be the ICO mint token buffer, means the address. Then we have to pass the program in which we have the program ID. So this is our ICO ATT. That's the first one. Now we have to take another one. We'll call this data PDA wait public key find address, in which we have to pass all the details like the buffer from, and we'll have the data and we'll pass the address of the admin which is connected. Let's convert it to a buffer. And the next one is going to be the program ID. That's the second one. Now we can come back here. Let's take a variable called admin ICO and we'll call this get associated token address, means this token should be associated with the admin because only admin can allow to execute this function. So we can take this mint token and the wallet address. Perfect. Now we can come back here. Then we have to use this await program and we have to call the method, and here we have to simply call our contract function we have. So we'll say create ICO ATT, and in which we have to pass few things because it's going to take the amount. That's the one thing we have to pass. So we'll take this new BNB and we'll pass the amount which we want to transfer to our contract. And here we have to define all the variables. So we'll take this accounts, then we can define the ICO ATA from ICO program, which is called ICO ATA PDA, because this is the unique address we have generated which is going to keep the token in the wallet, and then user can able to buy from it. That's the first thing. Then second thing is the data. We have the data PDA, we'll have the ICO mint, our token address. Then we'll have the for admin, the admin details, we already have it. Then we can take the admin wallet address and we'll have the system program, which is coming from system program. Let's make it the capital, and we'll take this program ID. Then we'll take the token program to be our token program ID, and we'll have the rent. And I can see the problem, it's PUB, it's PUB. So this is the fix we have to copy, and that's the same thing we have to update here. So it's where it is, it's here, it's PO. Make sure to replace it with PU. Perfect. And here we are passing all the argument to our contract. Perfect. Now we have to simply call it. So it's pretty easy. We'll say RPC, and I can getting this errors. Okay, I understand. Remove this one and save it. Now look perfect. This is all the details we are passing, and it's going to initialize our contract and transfer the token from the admin wallet to the user, to the contract. So looks fine. Now we have to wait and we have to display the alert. Once the transaction is successful, we'll say ICO initialized successful. Then we have to simply say await and call our fetch function, and we can come back here. Let's handle the error. We'll say error initializing ICO, and we'll have the error, and we have to throw the error message in the alert. We'll say error.message, and we'll take the final, and we're going to simply close the loader. Perfect. And this is the entire function we have which allows us to initialize our contract and deposit the token. Perfect. Looks good. Now close this one. Now we have to work on the next function which allows us to deposit the token. So we can simply copy that one and paste here, and let's change this to deposit ICO. So this function only called by the admin and it will deposit the token in the contract. So this is fine. I can simply return it. Here we have the program, looks fine, and here we have the ICO ATT data. Keep it as it is, don't need to do anything in here. And this is also fine because we need the data to transfer the fund. Perfect. This is good, no problem in that. And here we have the admin. So what I can do is I can see it looks good. We don't need to make any changes because we need the information about the admin. So it looks fine. And here I have to do the changes in the function. So let's call this deposit ICO in ATA, and that's the amount, but we need to pass. This is fine, and the argument is also fine. Now we have to adjust this one. So let's Let's remove a couple of things. So this is fine, this is fine. Here we have that, and we need the admin, and actually we don't need this one, remove this one. And we need the token program, remove this one. 6 details we need to provide. We're only passing the token to our contract, we're not creating the account. So that's what we have. Change the message to token deposited successfully, and thus the rest of the thing would be absolutely fine. So here we have the function which allow us to deposit the token in the contract. Perfect. Now we have to work on the last function which allow us to deposit a last function which allow the user to buy the token. So we can simply paste here, and let's change the name to buy tokens, and this is fine, this is fine. And let's come back here, and we have to do the conversion because we have to pass the amount to the contract, that how much user is spending. So we can come back here, let's call this sol cost, and we'll use the amount, and we have to multiply with this because this is the price of our token. So whatever quantity user will select, we're going to simply multiply with that. That's the first thing. Now we can come back here, let's take the balance, and we have to know the balance of the user. Do he really have, like, check the balance whether the user has the balance or not for performing the transaction, in which we have to simply pass the wallet address. Like whoever is connected with the wallet, we are checking the balance of that user. Then we have to build a if statement. We'll say balance is less than sol cost, and we have to deal with the 9 decimal point, and we have to add the extra buffer so we can take a perfect range to perform the transaction. You can play around with this value, but this value is suitable at the moment to execute the transaction. Inside that we can display the alert, means insufficient balance, need more balance to perform the transaction. So we'll go with the fix 3, and that's what I will say, and at the end we have to return it. That's the balance checks we are doing. Now we have to do the changes here, so it will be called ICO ATT PDA, same, because we need the information about the contract and the program. Then we have to need one more bump, because this is what we are passing in our buy function with the instruction, and this will also create the account for the user in the contract. So this is fine. Here we have the data PDA, which is also look good to me. We don't need to make any changes. Here we have this one. I guess here we have to do the changes. Remove this one called ICO data admin, because now we are dealing with the contract, and we have this one. Perfect. We have this one, remove this one. We can take a variable called user ICO AT, because we have to create the user data. We'll say await get associated token address, in which we have to pass the token address and the wallet. So this will tell us whether the token has the details about this account related to having it or not. So we got it. Now here we have to build a little bit system. We can come back here, we'll take this try and catch, and we'll say await get account, in which we can pass the connection and the user details. So this will give us the information whether the user already have the token or not. If not, then we're going to simply go with the next stage. There we can simply pass and create the account for the user. So we already have the model in which we have to pass the details like the wallet public key, the user, and the wallet, and the last one is the token address. So that's how we can create it. Perfect. Very simple, not that complicated. Now we can come back here, let's perform the transaction. We'll say this transaction, pass the details, call add, and in that we can simply pass the created one, and it will execute the transaction. So let's see, it's a transaction. Perfect. It's good. Now we can come back here, we'll take this await wallet send transaction, which take the transaction and the connection. Then we'll take the program promise dot all resolve, and we'll use the set timeout. I'm going to simply wait for a few seconds to confirm the transaction. So let's call this set timeout, and it will be for 2 seconds. Perfect. Once the connection and transaction established, then we'll simply move ahead and we'll call this particular function called buy tokens, and it's going to take one more argument. So let's come back here, we'll take the bump, and the amount is fine. We need to add few details. We need to add the details about the token like ATT as well. So we already have this all, and here I'm going to add the user detail because user will buy it. So let's come back here, user, and this will be user. We already have the information. This will be user. Let's paste this admin, and this admin data we already have it in ICO data. We'll call it admin. Perfect. We have the token program, which is absolutely fine. Now we have to get the system program and change this to system program, and we'll take the program ID, and this looks fine. Let's change this. This one is changed because we already have everything. We'll say successful purchase and the amount, and this is fine. And we have to call the user balance as well. This is the function we're going to create it, and the rest of the thing is going to be looks great. Don't need to make any changes. That's the only thing you have to do. Perfect. I hope you guys can follow me that what exactly we have done. Like I have taken the amount, I have taken all of the details. So now we have to work on this particular function called fetch user token balance. This is the last function, so we'll copy that one, close this one. Now we can come back here and you can see this is all we have. Looks good. Now we can come back here. Let's take a fetch user token function. It's going to be async, and here we have it, try and catch. We'll say if wallet connected, then we have to continue, otherwise we have to return nothing. We'll take that details, we'll take this user att, and we already have the details. We'll say get associate token address, in which we can pass the token address and the wallet. So in this way we can able to get the details about the user, about that token. We'll take a try and catch. We'll take the token account, get token account, will pass the connection and the user details. Then we can simply get the user token because it will have all the details like the connection and the balance. So from there we can able to access the account, and we're going to simply convert it to string. Got it? Now we can simply come back here. There we can simply take the error, and let's handle that. By default is going to be 0 if there is something goes wrong. And here we can simply come back here. We'll take the console.log, we'll display the error, and I get getting this one, save it. Perfect. And we'll set this to 0. So this is the function which allows us to simply get the balance of the token if user is connected. And that's the entire section we have. I hope you have understood. This is all the important function we need to write. And if I reload the page, if I do the inspect element, you can see that here we have all of the detail, no error we are having. If I come back here in the app.js file, and if I try to console log it, this particular one, in which you will find that we have all the wallet like mainnet, devnet and testnet. So come back here and you can see, reload the page, go back to the info, and here we have the details about the network. So we have accessed the devnet. In the same way you can access the mainnet and testnet, but when you are going with the mainnet, there you have to put your own custom RPC endpoint, because by default one will not work, it's depreciated. So you have to post your custom one, which you can get it from Acmeli, you can get it from Infura, you can get it for ARKM provider or Tatum. So that's the thing you have to keep in mind. So perfect. Come back here, we already have access that. So we have done with the main thing. Now we have to work on the front end part. So we can come back here, minimize this one, let's make it side by side so we can see what exactly we are working on. So let's do it one more time. I guess I missed it. Click here, and here we have that. Let's close this one and bring it on the right hand side. Perfect. And this is all the code we have coded. Now we have to start working on our front end. So let's come back here, let's take the return, and it will have a div. Let's have a class called class name. We'll take the min height, screen, background, gray 100. Then we'll take the paddings y6, pad flex column. We have a justify center. On a small screen, padding 12. Remove this one, take a div. It will have a class called relative. We'll have a padding 3. On a small screen size, we'll take this max WXL. We'll take the auto, and inside that we'll take a div. It will have a class called relative, padding x4, padding y10, white background, and we'll have the our on a small we'll have our shadow, and on a small grounded XL. Then we'll have our padding 20 on a small screen. Inside the div, we'll take a div. It will have a class called max with medium, and you can see that we are getting the styling. It will have a max auto. Inside that div, we'll take a div. It will have a class called padding bottom 8. Inside that, we'll take a div. It will have a class called flex, justify center, item center. Inside that, we'll take a h1 and we'll display our tag. So we'll take a class first. We'll take this called text 2xl. We'll take this font bold. We'll have a Solana ICO DApp. Perfect. Now we can come back here. We'll take our wallet connect. So this is the multiple wallet button is looking absolutely fine. Now we can simply come back here. We'll take a dynamic block. We'll say if the wallet is connected, then we have to display this particular component. So we'll take a div, and it will have a class called margin top 4 text small. We'll have text gray 600. Inside the div, we'll take a p. It will say wallet, and is going to display the void address. We'll slice it down to 8 character. Inside that, we have to display the wallet, and we have to simply slide it down to the last one. Simple, not that complicated. Now we can come back and let's take a p. It will have a class margin top 1. Inside that, we can say status, and we can display the status whether it's admin and the the user. So we can come back here. We'll say font semi bold, and we're going to have two different classes, one for the admin if the admin is connected or the user is connected. We'll say is admin is true, then we have to display this particular green one, else we can go with the bluish. So we'll say text blue 600, and that's the dynamic block, and we can display the message. So if admin is true, we'll say admin, otherwise user. So this will display that who is connected. Now we can come back here. We'll take the p. It will have a class called margin top 2 padding 2 background gray 500 rounded large. Inside that, we'll take a span. It will have a class called text gray 600, and inside the span we can say your token balance, in which we can display the balance of the user. We'll take this class. We can take another span. It will say font semi bold. In that, we can display the balance of the user. So we already have that one. So we can say user token balance. We have to simply divide by the 9 decimal point, and we have to get the first decimal. Otherwise, we can go with the else, which is 0. Perfect, simple. And here we'll say tokens. So this is our dynamic component once the user will connect it. Now come back here, let's check it. Let's make on the big screen to check everything, and you will find this is how it's going to look. If I click on reload the page, click on the void, and it's opening successfully, all of that. I can click on the phantom wallet, and here I'm connected. The void address is reflecting, the user status is getting perfect, and the balance is 0 at the moment. So every single thing is looking good, no problem so far. We have come back here, and let's make it side by side so see, and we start working and complete the code. So let's come back here, click being on the right side, and here we are. Now we have to simply come back here, and we have to take and work on the main component. So we'll come take the wallet connect. If it's true, then we'll take a div, and let's have a class called padding 8. Inside that, we'll take our dynamic block. We'll say if ICO data means the contract is initialized, and we have the data about the token, about the addresses and the connection. That's the data we have to, if we have those data, then we have to simply display in the component. So let's take that one, else we can go with the different one. So let's come back here. Let's take a div, and it will have a class. Let's call this margin bottom 8 padding 4 so we have all of that. So background gray rounded, border gray 200, looks fine. Inside that, we'll take the h2. It will have a class text large font semi bold, and we'll have bottom 3, and we can say ICO status. Now we can come back here. We'll take a div. It will have a class called grid column 2 gap 4 and text small. Inside that, we can take the div. It will have a class called text gray 600. Inside that, we can take this total supply, and we can take a p tag in which we can display the details. So it will be font medium, and we can display the total supply, that how much token is available in the contract, and we already have those data, total token, and we can call the string and whether token. Perfect. So this will display that how many token is available in the contract for ICO. Now what I want to do is I want to wrap this in a div. So let's come back here, and we're going to have the similar structure. So let's cut this and paste here. So this is the first one. Now we can simply copy this one and paste here, change this one to be tokens sold, and we can display the sold details, tokens sold. Copy and paste here. This will be price, and here we have to change and display the token price. So let's come back here, let's do the hard code because this is the price we have. Now close this one and copy the second one and paste here. Here we have to call this available, and here we have to pass and do the conversion. So we have the total which we're going to minus with the sold, so we get the available one. So we'll take this total minus with the sold one, remove this one, come back here, and we'll get the available token. Copy, paste here, and this one will have call your balance, and it will have the balance. So we already have the balance which we can display. So we'll take this number, user balance, and which we can do the multiplication and convert it to a fixed point too, and we go with the else statement, which is 0. Perfect. Hope this makes sense, looks perfect. Now close this one. This is all the section we have, and we can simply take these tokens. Now we can come back here, we'll say if it's admin, then we can display a different component. So we'll take this margin bottom, padding 4, background yellow, rounded large, border y, border yellow 200. Inside that we'll take a p tag, it will have a class called text yellow 700. In that we can display ICO need to be initialized. Perfect. So this message will display when the data is not available, that means the ICO is not initialized. So admin can initialize the ICO. Now we can come back here, we'll take a div, it will have a class called space y4. Inside that we'll take an input field, and we have to make this input field as a global, so it can be used for deposit and balance and initialize. So let's call this number, and it will have a value to be the amount. We'll have an on-chain function where we have to update into the amount, set amount e.target.value. When we'll display the, let's say, add the placeholder. So in that we can display that if it's admin, then we have to say ICO data, and we'll say amount of token to be deposit, else we go with the amount of token to be initialized. So this one is for the admin, if admin is connected, because admin can deposit and it can initialize. Else we can go with amount of token to buy. You can see it looks good, our input field. Now we have to apply the CSS, so we can come back here, let's apply the CSS. We'll take this width full, padding 3, border rounded large, focus ring 2, focus ring will have blue 500, focus line 500, and there we have, and we'll have the min, like min and step. Perfect, looks good. So this is our input field. Now we can come back here, let's take the dynamic block, will say admin amount. If amount or admin is not there, then we can simply display the div. It will have a class padding 4, background blue 50, rounded large, border blue 100, space y2. Inside that we'll take a div, it will have a class called flex, justifies between. Inside that we'll take a span token amount, and we'll display, take another span, we'll call this class called font medium, in which we have to display the amount and the token. Perfect. Now copy and paste here and change this to cost, and this will be our the price. So we'll have the amount which we have to multiply with the price, and you will get that particular amount. Now copy paste here and change this to be network fee, and it's going to be hardcode fee. So we'll say this one, and this one is the estimated range where you can able to execute the transaction without having any trouble. That's why I'm going with this. Now paste here and change this border top, padding top to flex, justifies between, font semi bold, and this will be called total, and this is called the our parse int amount. We're going to multiply with the amount and plus the fee network, and we'll say sold. Perfect. Now we can simply come back here and looks fine. Let's come back here. We'll take a dynamic blob. We'll say if it's admin, then we have to display the buttons for admin. So we'll take this div and we'll go with the else block. So we'll say if it's admin, let's apply the classes. We'll say space y3. Inside that, we'll take a dynamic condition. So we'll say if a contract detail is not there, then we have to display this particular button. Let's close this one. Let's add that on click, in which I can say create ICO AT. It will have the other property called disable, and we're going to call this loading. It will have the class called width full, padding 3, background blue, and text white rounded. On over effect, we can say background blue 700 and disable background gray 400, transition color, and in that we can display our button. We can say loading. If it's true, then we can say initializing. Otherwise, we can say initialize ICO. Perfect. This is the same button, and the same thing we have to do, copy and paste. So this is the button is ready, which admin can call and initialize the contract. That's the first thing. If the contract is not initialized, now we can come back here. We'll take another dynamic block. We'll say if the data is there, so we have to build the condition for the admin as well as the user. So we'll take this fragment, come here, and let's copy this button, paste here, and change this to getting this error. Simply remove this one. Now it's perfect. Now we have to change the function. So we'll call this deposit, and let's change the message to depositing, and remove this to deposit token. Simply copy and paste here. This one is for buy token processing, let's call this one, and we have the buy token. Now copy this one and go with the else one, and it's going to be the buy as well. There's no problem because user will buy. So here we can display the if not there. Perfect. This is good. Now we can come back here. We'll take this loading, and we'll take a div. It will have a class called text center animate plus text gray 600. Inside that, we can display processing transaction, and now we can simply come back to the last section. We'll display the wallet connect. If it's not connected, then we have to display this div. We'll take this padding 8 text center text gray 500 600, and we'll say please connect your wallet to continue. And that's the complete code we have written for our application. Now let's come back here, click on make on the big screen, and you can see this looks fine. If I reload the page, it's working absolutely fine. But I have noticed one thing, that I'm connected with the admin account, but still it's displaying user. So there is some problem we have in our admin check function, and the balance is also not reflecting. So there is a problem in our fetch token balance. If I see the inspect element, and then you will find that I'm getting some sort of error in the fetch function. So that's the one which I have to fix. Perfect. It's not a big deal. We have to do a little bit of auditing of our program, and it will make sense. So we have to fix those bugs. So let's do that in the next video. See you there. All of you, welcome back to the fourth part of our Solana ICO DApp project. This is where we left in the last video, where we have built the entire front end with all the logic. Now we're going to do the couple of fixing, and we're going to simply test all the features. So most probably this one is going to be the last video of this particular project. So this is where we left in the last video, and I want you to do a couple of changes right up here. So we are on the home page, and you will find that we have this void connected, which is absolutely fine. This is good, and I can come back here in the program, and here I have noticed one small problem. So you can simply come back here, and this is what you have to do. So I forgot to add this exclamation mark, so make sure to add it if you don't have it, and just keep all the thing as it is. So this is the one change you have to do. Once you're done with that change, now you can come back here in the check if admin. Now you can come back here, and here you have to do the changes. It's not array buffer, it's only buffer, because we have to get the data, then we have to format it. So that's why we can't take this one. So just take it buffer. So this is the one change you have to do, and the rest of the thing is going to be as it is. Now you can come back to the fetch ICO data. This is absolutely fine. You don't need to make any changes. We can come back here in the user information, and here we have to add the changes. So you can come back here, and this is the change you have to do. So it's a account, but you have to say amount, because we want to get the balance of the token. So we have the variable called amount, not account. So this is the one change you have to do. So, and the rest of the thing is going to be as is it. Okay, just make the thing as it is. Now if you save it, and you will find that this is how our application is going to look. Every single thing is working fine. Currently I'm connected with the admin account. That's what is reflecting. You can see the status, you can see the balance of the token I have, and right now our contract is not initialized. So admin has to initialize the contract, then the user can start buying. So here you can say ICO need to initialize. So all the logic is working absolutely fine. Now what I'm going to do is, I already have enough supply of the token, so I'm going to give 1000 token into the contract as a initialized deposit. Now click on this initialize ICO, and here it will ask you that system program is not defined. So that's the one we have to provide. So simply copy that one, and you can come back here, and here we have the function which we have to add. So let's do. That's why testing is very important. So here we have this create ICO, and we are getting this is fine. We are checking for the program, we are creating that one, this goods. Here we have the admin, because only admin can call the function, and we have the system program which is not defined. So if I check, and if I come back here, this is fine. So we have to import the system program from here. This is the system program. So you can see it's A given, so we have to say S. That will become SYSTEM. Sorry, it was a small typo. So when you will save it, now you can come back here and just click on this OK, reload the page, and now we can simply do one more time. So I'm connected with the admin account. Make sure you have to connect with the admin account, and I will give my initial deposit. So click on this initialize, and here it's processing. Just a moment. Here we have the Phantom wallet. Now I can give my credential for the Phantom, and you will find that we are making the transaction because we are initializing. So currently it's failed to stimulate the transaction. So this happened on the devnet. So simply click on this confirm, and you will find the transaction is initialized, and finally we have initialized the contract successfully. Click on OK. If you give a reload, and you will find all the details that how much token is available as an initialize is 1000. How many token we have sold is 0. This is the price of the token. This is the available token in the contract, and here we have our balance. Now if I come back here, and if I want to deposit more token, so let's test that deposit function we have built. So I want to deposit, let's say like 100 token more. So I click on this deposit token, and here I'm getting this particular error that like this method is not a function. So that's the one problem we have, which we have to look into that. Now for example, if I want to buy, let's take this buy as well. So click on this buy token. Here we are processing the transaction, and it's going to make a call to our Phantom wallet. Just wait. And we got this system program is not defined. So again we have to fix this particular typo. So I'll simply come back here, and first we have to go back to our buy function. So we have to fix our deposit function, and we have to also fix our buy function. So we can come back here, and here we have a problem. So it's a S system program. That's what we have given. So let's come back here on top. That's what we have. Now we can come back here, and let's give this, click on this buy token, and it's going to initialize. Just a moment, it's processing, and here we have this one. It's failed to stimulate the transaction, not a problem. Click on this confirm, and it's going to process the transaction. Once the transaction will complete, you will find that we have purchased the token. Now click on OK, and you will find that it went down and the fund is went up. So it's looking absolutely great. Reload the page, and you will find that we can able to buy the token. So buy and create and initialize function is working, but we have an issue in our deposit function. So what I can do, I can simply come back here. Let's try to deposit, let's say 122, and let's see what I'm getting. So I'm getting this particular error that program method is deposit is not a function. So this is an issue which I'm getting. Now what I will do, I'll simply come back here, and this is fine, and I have to open this one, and here we having the issue. We're getting the problem in the deposit function. So this is what we have. Every single thing is working fine. These variables are good, but this is the one which we're creating the problem. So maybe I have done some sort of typo. I can come back here, and this is what I have. I'll simply copy this one, copy the name of the function, and I can simply come here, and let's paste the name. Now what I will do, I'll simply make this capital. I hope you guys haven't forgot it. So let's make this one, and let's maze this. Okay, I think I made a mistake in the spelling, so let's give a try. Make sure to do this. Now you can come back here, give a reload, Now we are ready to deposit the token. So I can come back here. Let's deposit, for example, 100 token I want to deposit. I can click on this deposit token and here it's processing. So you can see it was a typo in the name. Again, I'm not getting that estimated costing and deposit because the simulation is failed. Don't need to worry about it. Click on confirm and the transaction is processing. So when the transaction will complete, and here we have got the complete and it will open to 1000 token. So every single thing is looking fine, that we can buy it, we can deposit it, and we have initialized. Perfect. Now what I will do, I'll simply come back here and I'm going to change my account. I'll come back to account number 2. I'll give a reload and you will find that I have connected with a user account. We have all the details and only option I have the buy token. So if I want to buy, I have this much token. I can give my money and I can buy the tokens. For example, I want to buy 100 token. And you will see this dynamic details are looking absolutely fine. Click on this buy token. The transaction is processing and I'm going to buy the token. So click on confirm and the transaction is processing. Once the transaction will complete, we have bought the token and went down, and here I got my balance up to 100. So every single thing is looking absolutely fine. This is how user can buy the token. If I want to buy, let's say 10 token more, I can buy it. I can simply click on the process and here the transaction is completed and we have bought the token. So it's a really powerful project. I hope you have understood that how you can develop this kind of project, because this project will help you to give you the understanding about the crypto environment in the Solana blockchain. So I can come back here, I can go back to the admin account, and there you will find out that I'm the admin and it will give me all the options. So if I want to deposit more or withdraw the token, I can click here and I can withdraw all the token. Let's say example, I want to withdraw 800 token. Click on this buy and it's going to withdraw automatically and I will have the token in my wallet. So click on this confirm and the transaction is in the process. Finally, click here and we have bought it. Now only 90 token is left in the contract. I can simply come back here. I can deposit, let's say 110 token and I'll make it 100. Click on this deposit and the transaction is processing. Click on confirm and the transaction would be completed. So I hope you have understood that how powerful this project is, what are the feature functionality we have included, and how every single thing is going to be working. So this is what finally we have completed the entire project. I hope you have learned something new in this project, that how you can build and write the contract, build this powerful project where you can add multiple condition, tons of things. So that's the only thing from my end. If you have any question in doubt, leave in the comment section. And if you want to get the final source code of this particular project, the link is in the description. You can get it and you can faster your development from there if you already have a experience in Solana, and that will help you a lot. So I can come back here and here you will find all the project we have developed. So you can simply come and check all of the project. This is the one we have. You can take the startup file and start building and following the complete project, or you can take the final source code. Or if you really want to master complete blockchain development, then I would suggest you to take this one. This particular bootcamp will teach you every single thing which you have to know to start blockchain. You're going to learn the programming language, the complete solid programming language, where you can learn and build actual smart contract for real world. And you will have the environment setup. You're going to learn about the project development on the blockchain. You're going to build 5 different contracts which are going to communicate. So it one is a really powerful project. Then you're going to learn about the required technology to build the front end and important packages. Then you're going to learn about the security which we're going to implement in the project which we have developed. After that, backend API, and this API can be used for Web3, Web2 in any kind of application. So you will learn the complete architecture. This bootcamp will teach you every single thing which you have to know as a blockchain developer. So I hope you have learned something new and mastered this particular project. If you want to check more projects related to the Solana blockchain, you can come back here, type simply Solana, and you will find all the project we have related to Solana. So you can create an NFT, ERC20 token. Here you will find the NFT creator, Solana full stack NFT marketplace, advanced presale, Solana token creator, airdrop. This is the advanced Solana presale. All of the project we have. This is the Solana swap token. So tons of feature we have. Here we have the most advanced Solana token creator with dynamic fees. This one is for the swap along with the token creation with a dynamic fee. So check all of this project. This will give you a better understanding about the Solana DApp. So that's the only thing from my end. If you have any question, any doubt, do let me in the comment section. I'll definitely try to help you in that. Have a wonderful day. Bye bye.